Hey guys, we're going to begin talking about exponential functions, all right? So before we dive into what, it all is and get really in the nitty-gritty, let's just kind of think of an example. Let's say we have bacteria and it grows at a rate of doubling every hour, okay? So what that means is in hour 1 is at 2, in hour 2 is at 4, in hour 3 it's at 8, in hour 4 it's at 16, in hour 5, it's at 32. In hour 6, it's at 64. So it just keeps doubling every hour. Is there a way I could write a function that models this? Well, I could say y is equal to 2 to the x. Okay? When x was 1, 2 raised to the first power is 1. When x was 2, 2 raised to the second power is 4. When x was 3, all right, 2 raised to the third power is 8. Okay, so and so on and so on. So in other words, if I want to draw this out as like a table, I could say this is the x, this is the y. Let's just pretend there were some negative hours in here too. There's not, but we're going to talk about why I'm doing that in a second. -3, -2, -1, 0, and then 1, 2, 3. All right, we already know 1, 2, 3. We know that if we plug in a 1, 2 to the first is just 2. 2 squared here, which is just simply 4. We maintain consistency. So 2 to the first, which is just 2. And then 2 to the third, which is just 8. Okay, so then what is 2 to the 0? Well, you might recall from Algebra 1 class that 2 to the 0 is simply 1. What is 2 raised to the -1? All right. You might also recall from Algebra 1 class that a negative exponent is not allowed. So what we do is you have to take whatever has the negative exponent and move it to the other side of the fraction. Now right now I don't see a fraction, okay? Well, 2 raised to the -1, you could drop that to being below a fraction bar, so it becomes 1 over 2 to the first, which then is just simply equal to 1 over 2, because 2 raised to the first power is just 2. All right, so then 2 raised to the -2 could be equal to 1 over 2 squared, which is just simply 1 over 4. Okay, and then we could also do -3. You'd say, okay, so that's 2 raised to the -3. I thought maybe this thinner marker size might help me write better, which is just then 1 over 2 cubed. All right, and then 2 cubed is simply 8, so it's just simply 1 over 8. All right. So then, if I wanted to, I could plot these guys on a graph. I could draw myself. Okay, that was a really bad line. Let me try doing that again. I could draw myself an x and y axis. All right, where this, is the y, and this is the x. All right, and I could say something along the lines of, so when it was a -3, 2, 3. When it, excuse me. When it was -3, I got about 1/8. So if this was 1/8 is probably, let me do this in a different color now. 1/8 is probably something about like right here. 1/4 is a little bit higher. 1/2 is a little bit higher than that. Then it's at 1. And then, when it's 1, you got 2. When it was 2, you went to 4. When it was 3, you went to 8. So 2, 3, 4, 5, 7, 8. So then, when it was 1, we went to 2. When it was 2, we went to 4. 1, 2, 3, 4. And when it was 3, we went all the way up here to 8. So then we looked something like this. Pretend I made this better. All right. And that it would be the shape of this exponential graph. Okay. So we started off with an example talking about what if bacteria doubled every hour. All right. Now, bacteria is going to go negative, so you could honestly kind of ignore this side for this example. All right? And you'll see that shoots up really fast. But let's go back to pretending bacteria's, the hours could be, why did I do that? Let's go back to pretending the hours could be negative. Notice how I go to the left and I get smaller and smaller and smaller. But let me ask you something. If you were to continue going like -4, -5, -6, would you ever actually get to a negative y value? You can check that on a calculator. Just you know, if you go to 2 raised to the -4, would you get to, is that negative? Is that even 0? No. 2 raised to the -5. No. 2 raised to the -6. Is this negative or 0? No. So you'll notice that I never actually ever drop below this x-axis, okay? That's because there's no number that I could plug in for x that would make the y value become 0 or negative, okay? Not when it's just looks like this. So what we say is that the exponential function has what's called an asymptote. Asymptote. I'm pretty sure I'm spelling that correctly. Okay? And that's drawn on a graph. That's an O right there, not a 6. And that's drawn on a graph by a dotted line. Okay? And it just goes across the x-axis. And sometimes you'll see it referred to as the x-axis. Alright, but sometimes you'll also see it being referred to by y equals 0. Now that's not the only place an asymptote can exist, but that is the location of the asymptote for this example. Okay? So it just goes straight across, dot, dot, dot. Alright? So the red line will continue to go to the left forever, but it'll never cross over the x-axis. So then what would that make this domain? Okay, let's just talk about that real fast. What would make this what is the domain then of this red graph, of this exponential graph? Well, I hope you say, well, Mr. Nell, it's still going to the left forever, and it's still going to the right forever because it continues to go to the right. So it's just going to be all real numbers. Or you can just say negative infinity to positive infinity. Now, what about the range? Well, that gets a little trickier for some students. What appears to be my lowest y value? Well, you say it keeps getting lower and lower, but you said never touch 0. So I don't really know what my lowest y value is. Well, what we do is we say that 0 is our lowest y value because that red line will get closer and closer and closer and closer to 0, but it'll never actually touch 0. So what we do is we put a parenthesis there, meaning, hey, we get infinitely close to 0, but we don't ever touch it. That's what the parenthesis tells me. Comma, and then what do I do after that? What does this red graph do after that? It shoots upwards. So that would be infinity. And that would be the domain and range of this guy. Alright, so this is the basics of an exponential function. Alright, so let's look at the parent function for exponential function. Alright, so this is the actual parent function. Okay, the parent function is simply y equals b raised to the x. Alright, so it's y equals b raised to x. B is just a constant. B is a constant. That means b can be any number. Okay? But the different numbers b takes on changes things. Okay? If b is greater than 1, we call that, and you do want to write this down, we call this exponential growth. That was an example we just saw. I'm just going to write exp to represent exponential growth. Okay? We just saw an exponential growth. But what if b is between 0 and 1? Okay? What does that mean? Well, that's called exponential decay. And I'm going to show you what happens on that. Okay? That's called exponential decay. So let's say you were, take our last example, we had bacteria doubling every hour. Well, you found a way to cure it, and it killed it off. I'm making this up. I don't even know if this is possible. But it killed it off at a rate of 1/4, 25% every hour. You killed off 25% every hour. Okay? So, your b value then was 0.25, or 1/4. I'm going to do it with 1/4. Alright, just because more often we see fractions, But 0.25 would be acceptable also. So you're saying that you're killing off germs at a rate of 1/4, okay? So that's your B value. So right now we have something that looks like y is equal to 1/4 raised to the x, okay? So for every hour, you kill off 1/4 of the germs, okay? So then, what that actually does to your graph, here, let's just look at the way the calculator does it. All right, what that does to your graph, you do 1 divided by 4 raised to the x. You can hit graph, but I know I need to hit zoom 6. So I hit zoom 6. What's different about this graph? Take a moment, compared to the graph we just did. Look at your notes. What's different? It's going the other way. This type of graph is referred to as exponential decay. When your graph is falling from left to right, so that means it's going downwards from left to right. So it looks something like this. That's referred to as exponential decay. Now, at this point in time, it actually still has the same asymptote. It still has the asymptote at x equals 0. I'm sorry, y equals 0, or the x-axis. Okay, the asymptote is still there. Okay, so that didn't change. Okay, the only way the asymptote changes is if you shift the graph up or down. Then the asymptote moves at however far you shift it up or however far you shift it down, which is not really our focus for today, but I just wanted to go ahead and make that statement. So if your B value is between 0 and 1, you get exponential decay. Notice, I said your B must be between 0 and 1. We have not dealt with a negative B. All right? We will not deal with a negative B. All right? So just remember that. All right? So what we've covered so far is the parent function. The parent function is y equals b raised to the x, where b is a constant. The constant means it's just some number. There are two different types of exponential graphs. Exponential growth, which means that it's rising from left to right, and it still has that asymptote, which is a line I can never touch or cross, but it still has that asymptote right there at y equals 0, or the x-axis, however you want to remember it. Then, if b, your constant, is between 0 and 1, then we have exponential decay, which means I'm falling from left to right. All right, something like that. But you still have your asymptote at y equals 0. All right? Something else you should just make sure you make yourself aware of. That was all the parent function stuff. The general format for writing exponential functions, okay, so the general format is y equals a times b raised to the x. All right? This is just what we call the general format for writing exponential functions, where a is just some constant also. But let me ask you a question. Let's say I gave you this idea right here. Y is equal to 2 times 3 raised to the x. I have a lot of students that try to say y equals 6 to the x here. Wrong. Cannot do that. See how this 3 is being raised to the x? Okay? So the 2 are not like terms. The 2 is not being raised to the x. Only the 3 is. So they must remain separated. Okay? Something you might want to know about y equals a b to the x. Alright? A is commonly referred to as your first term or initial quantity. Okay? Just so you're aware. A is commonly referred to as your first term or your initial quantity. Alright? So this is what we call the general form for writing. Alright? This is what we call the general form. Okay? Now, there's another way of writing it that you will see quite often. And that is y equals a, so it's the same a, but then they make b become 1 plus r raised to the x, where r is just your rate of change, okay? It's just simply your rate of change, all right? So, just a quick random example on using this idea right here, okay? Just a quick random example. The quick random example is this. You deposit $1,500 in an account that pays 5% interest yearly. How much money do you have after 6 years? Okay? So, This is where y'all heard the term compound interest. This is where compound interest kind of comes into play. All right, exponential functions deal with compound interest. Okay, we're going to take this formula and use it. Okay, now hopefully you notice the difference between the general form and this is they keep the same a, but they just changed b to being 1 plus r. Okay, the only reason they do that is to help students realize proper b values. Okay, you don't actually have to use this formula. You can use this formula if you understand what b is. B is still your change, okay? But a lot of students struggle understanding what the change is on this next example. You deposit $1,500 in an account that pays 5% interest yearly. Do you know what most students try to say b equals then? They try to say b equals 0.05, okay? B does not equal 0.05. No. B is the total change, okay? R equals 0.05, okay? Because think about this for a second. If you're getting paid 5% interest yearly, okay, does that mean that you need to multiply your prior year by 5% and just take that? Okay? Let's say you have this $1,500 and you expect to get 5%. So you take this $1,500. I can't get this to turn on. It takes so much. Okay. So you take this $1,500 and you multiply it by 0.05. And you're like, sweet, this is how much money I should have in my account at the end of this year. $75? That's all I should have? That doesn't sound right. What do you have to do with that? You add it back in. So wait, how much money do you really have at the end of the year? You have $1,575. So you have 100% of your money plus another 5%. So wait, you have 100%, so in non-percent that's 1, plus 0.05. So you really have 1.05 of your money. That's the difference in these formulas, okay? B should really be 1.05, but students struggle with that, so we give you this formula so that instead of doing everything I just did, you could have just said, okay, so I need to say y is equal to A, that's my initial amount, which would be 1,500, times 1 plus R. Okay, what was my rate of change? What was I changing from year to year? 5%, so 0.05, raised to the, how many years am I trying to do this for? 6. So we give you this formula so that way you don't have to try to think about, okay, what is A, what is, you don't have to think about what is B entirely. See, B does not equal 0.05. B really should equal 1.05. R equals 0.05. So then we just can type this all in the calculator. Now, this is after all 6 years. This 1575 was just after 1 year. This formula is going to allow me to figure it out after all 6 years. So 1.05 raised to the 6th. Press enter, and I get $2,010.14. And I'm only going to round to 2 decimals because we're dealing with money, so it makes sense that I only round to 2 decimals. So $2,010.14. That's a money symbol. Okay? Okay, so I hope that video was helpful. You guys really need to make sure that after you watch this video, I know it's 20 minutes, I do apologize for the length, that you go and take the 5-question quiz, because that's how I'm going to check to make sure you watch this. Okay? All right, let me know if you have any other questions.